Hello, so I'm going to be doing this video on formal charge and oxidation number, and I guess overall charge as well, because it's related. So let's look at this molecule, iodine, with 4 fluorines, so this is IF4. Now, to determine let me just draw the lone pairs first. Okay, so to determine the formal charge on iodine, what we need to do is, first of all, determine the number of valence electrons that iodine has. So iodine has 7 valence electrons. Okay, now what we're going to do is count the number of electrons that are surrounding iodine. So what's immediately around it? So we're going to count 1, 2, 3, 4. This is 1, 5, 6, 7, 8. So that means iodine has 1 extra. It has 1 extra negative charge. So 7 minus 8 is -1. -1. It's got a -1 charge because it's got 1 extra negative charge. Okay, so that's formal charge. Now, I'm going to erase this. So -1. Now, if we look at fluorine, fluorine has 7 valence electrons as well. And so let's look at this top fluorine here. I see 1 electron, 2 electrons, 3, 4, 5, 6, 7. So that's 7 surrounding it. That means it does not have a formal charge. It has a formal charge of 0. And so overall charge is just the sum of the formal charge of all of the atoms. And so since all of the fluorines are identical, they all have a formal charge of 0. That means the total overall charge is -1. Now let's do the oxidation number. So oxidation number is basically the temporary formal charge of an atom if each bond is an ionic bond, meaning it is fully going to assimilate an electron from the less electronegative atom. So the more electronegative atom, it's going to fully assimilate an electron from a less electronegative atom. So in this case, fluorine is going to be more electronegative than iodine because fluorine is the most electronegative element on the periodic table. And so therefore, oxidation number of iodine is, now per single bond, per line basically, iodine is going to lose 1 electron to fluorine per line. So if iodine is losing 4 electrons, That means it's plus 4 because it's losing 4 negative charge. Therefore, it's positive 4. Now, but look, iodine started out with an extra negative charge. So we have to count for that. So we have to add -1. That means the oxidation number of iodine is plus 4 plus -1, so plus 4 minus 1, and that's plus 3. So that's how you do that. Now let's try something a little bit more challenging. Okay, so this one is a bit more challenging. So we have to figure out, what I'm going to do is I'm going to figure out the formal charge of nitrogen first. So formal charge of nitrogen is going to look like this. Again, we're going to figure out the valence electrons of nitrogen, and that is 5. And how many is immediately surrounding nitrogen? Well, 1, 2, 3, 4. So nitrogen has 4 electrons surrounding it. So what does that mean? It means nitrogen is missing 1 electron. If it's missing 1 negative charge, it's plus 1. Let's look at the formal charge of O. So this O here. Again, we're going to do the same thing like we did for nitrogen. We're going to look at, the electrons immediately surrounding it. So I've got 1, 2, 3, 4, 5, 6, 7. And valence electrons of O, it should have 6. But O has 7 electrons surrounding it. That means it has 1 extra. 1 extra negative charge makes it -1. So we have negative here and a positive here. And lastly, this O, again, we're going to count the number of electrons surrounding it. So 1, 2, 3, 4, 5, 6. So it has the correct number of electrons surrounding it. Therefore, it doesn't have a formal charge. It's got a formal charge of 0. And it's important to note that even though I didn't write it out, each of these corners represents a carbon. And carbon normally carbon has 4 valence electrons, so it's capable of forming 4 bonds, 4 single bonds, or 1 double bond and 2 single bonds, or 1 triple bond and 1 single bond. So 4 lines, essentially, coming out of it. And so each one of these carbons has already has 4 lines coming out of it. And so therefore, they don't have a formal charge, and H only has 1 electron. And so all of these all have the formal charge of 0. And that means the only 2 atoms with a formal charge is nitrogen and this oxygen. And so +1 minus 1 equals 0. And therefore, the overall charge is 0. Now let's look at the oxidation number of nitrogen. So oxidation number of nitrogen is a little bit more tricky. So what I like to do is write out BC0. And that is the order of the elements on the second row of the periodic table, going from left to right. The electronegativity goes up when we go from left to right. And so what we see is that oxygen is more electronegative than nitrogen, and nitrogen is more electronegative than carbon. And so that means with each line that nitrogen has with oxygen, because nitrogen is less electronegative than O, oxygen is going to be stealing 1 electron from N per line that it has bonded to nitrogen. So that's 1, 2, 3. And because carbon is less electronegative than nitrogen, nitrogen is going to be stealing 1 electron from carbon per line with carbon. So like this. So to sum it up, nitrogen is losing 3 electrons to the O's. So losing electrons means plus 3, but it's gaining 1 electron from carbon. So it's gaining a negative charge. So gains -1. But don't forget, there's a formal charge of +1 on the N because it has lost an electron to begin with. So plus 1. So +3 minus 1 plus 1 is +3. And that's how you do oxidation number.